We tend to think of the moon as a gray and silent environment, tranquil, always the same and even monotonous. However, on April 6, 2026, when the astronauts of the Artemis mission, two of them, passing through the far side of the satellite, found a completely different reality. The lunar surface proved to be a place of constant impacts at very high speeds, and that serene world we expected was, in fact, quite frightening. But before we begin, don't forget to like and subscribe to our channel. The first significant change was felt immediately: the sound, or more precisely, the absolute and sudden silence. Inside the Orion capsule, there is always a continuous noise produced by fans, electronic devices, and cooling systems. However, as soon as they passed the lunar edge and the moon interrupted the line of communication with Earth, all S-band radio transmissions and all high-speed data connections were simply cut off. It wasn't a technical problem, but a complete communications blackout that lasted precisely 40 minutes. At that moment, the crew was 406,761 kilometers away from the planet, setting a new distance record for human beings. They were, in effect, the most isolated people in human history. No one on Earth could hear them. No one could communicate with them. If any problem arose, they would be completely alone. The visual scene was even more disconcerting. While in the shadow of the moon, the crew experienced a solar eclipse that lasted about 54 minutes. Because there is no atmosphere on the moon to scatter light, the moon did not appear as a bright object in the sky, but as a hole in the universe. Commander Reed Wiseman described it as a giant backlit black disk, so dark that it completely obscured both the sun and the Earth at the same time. How do you navigate when your main points of reference disappear? The psychological impact was powerful. We often hear about the panoramic effect, where astronauts feel a deep connection to Earth. The Artemis Crew 2 experienced the exact opposite, a complete breakup. They were moving at thousands of kilometers per hour through territory where no one could reach them if something went wrong. For those 40 minutes, the four of them were the only living things in a literal void. Suddenly, the scale of the far side of the moon seemed far more aggressive. It stopped looking like a moon and began to resemble a massive physical barrier between them and all other people who had ever lived. The crew sat there amidst the hum of the spacecraft's electronic equipment, simply waiting for the deep space network to pick up their signal again from the other side. But as they would soon discover, the darkness was not empty. It was brimming with kinetic energy that no one was truly prepared for. And what happened next? Captured by the Artemis cameras. To do would shock NASA and forever change the way we think about the moon. The most disconcerting part of the flyby happened when the crew actually saw the surface changing right in front of them. It turns out that the far side of the moon isn't the static, ancient graveyard we usually see in high-resolution orbital photos. While passing over the dark side, the Artemis crew 2 reported seeing 6 distinct flashes of light on the surface. They were not city lights or some kind of technical malfunction in the windows. According to data from NASA's Meteoroid Environment Office, these were high-speed kinetic impacts happening in real time. The physics behind it is straightforward, but difficult to grasp when you witness it with your own eyes. On Earth, our atmosphere acts as a protective shield. It slows down incoming objects and burns them up through friction. But the moon essentially has zero atmospheric pressure. This means that a rock the size of a marble traveling at 30 kilometers per second hits the ground with all its momentum intact. It doesn't just make a hole, it transforms into a tiny, momentary star. What the crew was witnessing was the direct conversion of kinetic energy into thermal energy and light. When these objects struck the regolith, the heat was so intense that it instantly vaporized both the impactor and a portion of the lunar soil. This created a small, bright cloud of plasma, bright enough to be visible from an altitude of several thousand kilometers. Astronauts Jeremy Hansen and Reed Wiseman was observing a process that has been shaping the moon for billions of years. Seeing 6 impacts in such a short time window made it clear that the lunar environment is far more active than the public generally assumes. This discovery immediately raised serious concerns about the vulnerability of the Orion spacecraft itself. The capsule is built to withstand radiation and the extreme heat of re-entry, but it is not an armored tank. A meteoroid the size of a marble hitting the hull at those speeds would be catastrophic. Being on the far side meant the crew was completely exposed to the constant stream of debris that Earth's gravity usually helps deflect, or that our atmosphere normally destroys. These impacts are not only a threat to the spacecraft, They represent a huge challenge for any future lunar habitation. If the far side is being bombarded with this frequency, any long-term structures would need to be buried under several meters of regolith simply to survive the relentless bombardment. The crew wasn't watching a pretty light show. They were witnessing the main reason why the moon remains such a hostile place for biology. Even the dust kicked up by these impacts is dangerous. Researchers studied how secondary ejecta particles can remain in temporary lunar orbit, or wear away anything nearby through abrasion for extended periods. While the crew observed the hidden side, they were also moving through a debris field that never truly clears up. The realization that the ground beneath them was exploding in real time changed the entire atmosphere inside the cabin. What began as a scientific survey quickly turned into a survival exercise. The moon is not just a peaceful neighbor. It's a world that is being actively reshaped by the violence of the solar system every hour, and the Artemis cameras are showing this. Two of them captured each flash in stunning detail, giving NASA an unprecedented view of just how dynamic our nearest celestial body really is. In fact, one of the most disorienting parts of the flyby was the way shadows behaved on the lunar surface. We're used to seeing shadows on Earth that have a bit of blue or gray in them because our atmosphere scatters light into dark spots. But the moon has no air at all. This means there is no light scattering whatsoever. When Victor Glover looked out the window at the lunar terminator, the sharp line where day meets night, he saw something that didn't look like normal geology. He described the valleys as looking like actual black holes. Without any atmosphere to diffuse sunlight, a shadow on the moon is a perfect ink-like black void. Recorded by the Orion cameras, you can see these sharp, jagged edges where the light simply stops. Glover mentioned that he felt like he was falling straight into the center of the moon. The reason for this feeling is a complete breakdown in depth perception. Human eyes rely on atmospheric perspective to judge distances. On Earth, distant mountains appear somewhat hazy or bluish. But on the far side of the moon, a mountain peak 80 kilometers away appears as sharp and clear as a rock just 1.5 meters from the capsule. This lack of haze makes the scale of the far side's topography seem overwhelming. The crew was passing over the South Pole, Aitken Basin, one of the largest and deepest impact structures in the entire solar system. Some of these craters have walls several kilometers high. When these walls cast shadows, they create massive zones of absolute darkness that can swallow entire mountain ranges. This isn't just a visual trick. It's a major technical challenge for any future landing. If your eyes and sensors can't distinguish between a shallow depression and a 300-meter drop because both look like an endless black hole, the descent becomes incredibly dangerous. The crew had to rely heavily on laser altimetry to know where the ground actually was. Glover's observation highlighted how empty the dark side appears. Even when the sun is hitting the peaks, the rest of the landscape seems to be missing. This creates a sensory mismatch that the human brain simply hasn't evolved to handle. This constant, unsettling sensation of the ground being pulled from beneath you becomes even more intense when you're traveling at 8,000 kilometers per hour. The optical void begins to feel like it's actively pulling you inward. It turns out that the most terrifying thing about the far side isn't the rocks you can see, but the fact that most of the landscape remains essentially invisible until you're almost standing on it. We always assume that seeing is believing, but on the moon, your eyes are effectively lying to you. The Artemis cameras. 2. Captured these dramatic contrasts with stunning clarity, showing a world where light and darkness behave in ways that seem almost alien. The dark side isn't just remote. It plays tricks on the mind and challenges all our instincts for survival in unfamiliar territory. Navigating a spacecraft around the moon should be a problem solved by physics, but the telemetry records from Artemis 2 revealed something unexpected. When Orion reached its periselenium, the point closest to the lunar surface, its speed increased by 0.7 millimeters per second beyond what all models had predicted. It doesn't seem like much, but for a mission that relies on precise burns to reach a narrow atmospheric entry corridor back to Earth, any unexplained acceleration is a serious concern. This is a recurring puzzle known as flyby anomaly. Scientists from the University of Bologna and elsewhere have been studying whether this results from some subtle interaction with dark matter, an error in how we calculate Doppler shifts in radio signals, or something completely different. The fact that it occurred during this manned flight means that the far side of the moon still holds variables that we don't fully control. Even our best gravitational models are only approximations when put to the ultimate test. But the physics of the orbit wasn't the only surprise hitting the crew with unexpected data. They were flying right at the peak of solar cycle 25, with the sun launching high-energy particles at rates not seen in decades. The moon doesn't have a global magnetic field, so nothing deflects these solar particles. The crew relied on the Hybrid Electron Radiation Evaluator, HERA, to monitor the environment inside the capsule. Radiation levels proved to be significantly higher than expected. Assigning names to these impact sites is really more than just making maps. When the crew identified two exceptionally bright features in the South Pole Aitken Basin, they were looking at areas that hadn't been worn down by the solar wind for a long time. These are the craters they named Integrity and Carroll. Placing human labels on such a hostile environment is our way of trying to make sense of the void and reclaim a small piece of the unknown. If you look at the raw images from Orion's CMOS sensors, the ejecta surrounding these craters are incredibly white. This suggests that the material was excavated very recently, in lunar terms, within the last few million years, which is essentially yesterday on a geological scale. These fresh scars became some of the only clear landmarks the crew had in a region that is otherwise a repetitive and heavily battered desert. The near side of the moon tells ancient stories in its names, but the far side remains a dangerous mystery. There, names offer no protection against chasms 13 kilometers deep. Future landing modules will face a Herculean challenge, navigating monumental shadows in terrain where the bright, churned-up soil serves as a warning that the impact of debris never ceases. Our vision of a sleeping moon is a thing of the past. Today we know that the satellite is a vibrant, dangerous environment, laden with radiation far more intense than measured in the 1960s. The moon is now our trial by fire. If we learn to survive its gravitational traps and its flashes of light, we will finally be ready for the journey to the red planet.